right approach. With clarity, the thermodynamic model. I think this will be very useful for all the participants who are the users of the CPP in evaluating the degradation in the right spot and not make a mistake in pinpointing where it is there and try to achieve what is possible under the circumstances. Thanks. Now, Dr. Andritz, I was told, is not able to be available. Just a brief. I have a great request. Because of the severity of the conditions, especially in the stack emission, and Dr. Andritz as well as ESTEC has agreed to make a presentation, especially relating to the FGD as well as the mercury control. For the MOEF CCS come out with a stringent regulation of 100 milligrams per nm³ for SOx and 0.03 milligram for mercury for all the power, not only for thermal power plant, but also for the captive power plants for the industry. I thought it fit to have an expert in this field. Was got, I think, Dr. Andritz with these 40 years of experience, and ESTEC Heston, Vice President of ISOTEC, was done extensively on this particular subject, both on the FGD as also, I think, on the wastewater management, especially for the steel sector. I thought it fit to hear them what he is to offer with the experience and the case study, and how does it fit in for the Indian coal, which has started getting mercury, how we are going to control both FGD as well as mercury, both DSOx and mercury, with, of course, not at the cost of the energy level. And I thought we are looking forward to Mr. ESTEC presentation. ESTEC, you have 20 minutes. I think with that, you can absolutely give your the best of this, what you have done for our Indian participants of the coal CPP. Over to you, Mr. ESTEC. Are you there, Mr. Heston? Hello?
Sir, please mute yourself.
Okay. Can you hear me?
Yes, sir, we can hear you.
Okay, then I will try to share my presentation. Can you see my presentation?
Yes, sir. Can you put it in slides? Yes, it is visible.
Okay. So have a good day. Thank you for introduction, Mr. Chairman. It is my pleasure to have an opportunity to present the auditorium in India and worldwide our experiences on wet FGD process, as well as wastewater management, with the accent on multi-pollutant removal in thermal power plants. I have to excuse the absence of my co-speaker, Dr. Sregarshek, who unfortunately does not have opportunity to participate today. Let me at the beginning share a few basic information regarding ESOTEC company. ESOTEC is located in Slovenia in Europe, and it is a joint stock company with almost 70 years of tradition, which is acting at the market as an EPC contractor. ESOTEC has a know-how for a design and execution of different industrial processes, especially air pollution control systems and water treatment management. Our orientation is to achieve marketing goals at each individual market with local strategic partners, and that is why we have established cooperation with a local company in India named Enviropol Engineers. ESOTEC solutions and products are ranked into two portfolios. One of them is environment and the second is power engineering. Our scope of services starts with consulting and all phases of design, shop drawing, manufacturing, procurement, construction, supervision, commissioning, and also we offer after sales maintenance and other services. We combine our research and development activities with EPC projects for our clients. Some of our projects will be presented in continuation. At a time when desulfurization was not yet in industrial use, engineers built high stacks in order to reduce impact of SO2 on local community. As a result, the destructive impact is spread to a wider area with the negative consequences on nature and human being. Such a case is thermal power plant in Trbovlje in Slovenia, built in the 80s of previous century, with 360-meter high flue gas stack, and this stack is highest stack in Europe and 7th highest in the world. At the beginning of the century, a client decided to upgrade the existing plant with FGD, and Esotech carried out complete project documentation and a part of mechanical supplies and installation. Now I will move to the next thermal power plant. It's named Šoštanj. It is the largest Slovenian coal-fired thermal power plant. Initially, dry FGD system was introduced by Esotech for all units, I mean units 1 to 5, which was changed afterwards on wet FGD for units 4 and 5. In 2015, new 600 megawatt unit with wet FGD and water treatment system built by Esotech started his operation. FGD operates without gas heater. Flue gases are directed into the atmosphere via cooling tower, and it operates without wastewater. I would like to say that this is lignite coal fire plant. Here are data about flue gas flow rate at the inlet and inlet concentration. You can see the figures, I will not read it, and outlet emission concentrations, which ranks thermal power plant Šoštanj among the most efficient in Europe. You can see that SO2 concentration is less than 100 milligram per normal cubic meters, and this is state regulation. Regulation about before the thermal power plant get permission to start erection. After process chemistry calculation and basis design, we continue our design with CFD modeling in order to optimize our solution. In terms of flue gas velocities harmonization, over the absorber cross section, you can see flue gas velocities in this cross section, and to achieve most efficient SO2 reduction in the FGD plant. There are 4 pictures. This is inlet, and this is on the top of the absorber. We continue with detailed design, procurement, erection, and commissioning, and here is a view on erected FGD plant at thermal power plant Šoštanj. You can see plastic C-tube on the top of the absorber, which introduce flue gases to the cooling tower. Our FGD references are not only connected with thermal power plants, we have developed also FGD process for other industries. Here is an example of FGD in the industry of processing secondary lead raw material. Challenge for the process engineers are extremely high and variable SO2 inlet concentration from almost 0 to 14 milligrams per normal cubic meter. Here is the view on the plant. Esotech has the knowledge that also that it can prepare a comprehensive feasibility study to serve decision makers on the decision of cost effectiveness of the potential new thermal power plant construction. This is the case in Tuzla, in Bosnia and Herzegovina. And the next case for thermal power plant Plevia in Montenegro, which is done by Esotech. Our ongoing feasibility study is for thermal power plant Kakan in Bosnia and Herzegovina. In addition to an environmental friendly FGD system, sustainable water management also plays an important role in thermal power plants. I have in mind both boiler makeup water as well as different kind of wastewater generated in thermal power plants. At first, water treatment system for thermal power plant Shoston will be presented, a general overview, and then pumping station, decarbonization plant, bypass filtration for main cooling system, and closing gates on the river Paka. Besides the water treatment system, I would like to present also an example of wastewater treatment solution which is built in the biggest Serbian thermal power plant in Nikola Tesla, Obrenovac, which consists of sanitary wastewater treatment plant, heavy oil and oily wastewater treatment plant, lignite coal wastewater treatment plant, and also flue gas desulfurization wastewater treatment plant. Here are some photos of first is flue gas desulfurization wastewater treatment plant, then lignite coal, oily waters, and heavy oil wastewater treatment plant. Now I will become into the second part of my presentation. This is a mercury removal case. So, as you know, besides SO2, there are many other pollutants in the flue gases that require the control. For example, NOx, chlorides, etc. Lately, toxic mercury gains a lot of attention as a globally binding measures have to be taken by nations to decrease its emissions to air. Consequently, emission standards are more and more stringent, being few years ago 50 micrograms per cubic meters and going down as far as to 1 microgram per cubic meter. In flue gases, mercury appears in different chemical species, elemental, oxidized and bound to particles mercury. Oxidized and particle-bound mercury are soluble in water solution, while elemental mercury is only slightly soluble. This results in the fact that majority of elemental mercury passes wet FGD process and goes to the atmosphere. In 620 megawatt thermal we observed very unusual situation. It is that elemental mercury was removed in a classical wet FGD by roughly 76%. Oxidized and bound on particles behave likely expected, with high degree of removal. The table on the right side shows the concentrations of 3 species before and after wet FGD. Slide shows the mass balance of the total mercury in the lignite power plant in Slovenia. Almost exclusive input of mercury to the system is the coal. Output are 8% for fly ash and slag, 11% in flue gas to atmosphere, and 81% in gypsum. It is worth saying that about 90% of mercury in gypsum is present in the fine fraction, representing about 12% of gypsum. This behavior offers a good opportunity to separate the majority of absorbed mercury in a relatively small stream of solid waste. In order to explain high removal rate of elemental mercury, we started the laboratory investigations. The picture shows the experimental arrangement where we simulated the process in the absorber bottom tank where intensive oxidation by air of dissolved SO2 is taking place. We spiked the air with SO2 and mercury and measured the absorption degree for elemental mercury. We found the most influential parameters for simultaneous SO2 and elemental mercury oxidation in wet FGD. First parameter is the concentration of sulfite in the solution, the optimal concentration of sulfite for mercury. Removal fits the optimum for SO2. You can see very narrow area of sulfite concentration when mercury removal is successful. Next important parameter is supply of oxygen, I mean air, to the solution. You can see also the values of air or oxygen introduced to the solution. Next crucial parameter for oxidation is also the presence of catalysts like transition metals. The whole tentative model of chemistry is given in this picture, described in the cited article and other published work of the same authors. The general conclusion is, it is possible to dissolve and oxidize elemental mercury in the conditions of wet FGD by maintaining proper chemical conditions as described above. In next two slides, the technical comparison between this developing technology and two commercial technologies, I mean active carbon addition in the flue gas and bromide addition to the coal is given. You can see almost the same removal efficiency, but the big discrepancy in energy consumption of both three cases. Active carbon addition requires very significant investment in the equipment, I mean back filter, additional fan, in order to separate mercury contaminated carbon from the fly ash, which is used by construction companies. Operating costs are high due to electricity consumption, active carbon consumption, and hazardous waste generation. Bromide addition is very simple, however, the cost of bromides is high, and we have additional bromide emissions to the air. Catalytic mercury oxidation in wet FGD by air is simple, with very moderate consumption of energy and catalysts and does not increase the emission to atmosphere. Preliminary cost estimating gives the new technology great credit in respect to two others and justify the testing on the industrial boiler. I would like to thank you for your attention, and if you have any questions, you are welcome to address them to our addresses. Thank you for again.
Thank you, Ilker, for an excellent presentation. I think it is an eye-opener. I think all the participants would have really enjoyed and benefited by this sort of technology, which is what we are looking in for. Because I just want to share the latest regulation from Ministry of Environment, Forest and Climate Change in India has stipulated 100 milligrams for SO2. As also mercury on 0.03 milligram. So earlier it was not there. Now all the power plants has to necessarily follow after 2018. So I thought this is an excellent lecture on this subject, which is of growing interest, not only for the captive power plants of the industry, but also for the thermal power plants. Thanks for accepting our invitation and having excellent speech, which is of benefit. Thank you once again. right? Now, Kiran, if you have the question and answer, if you have time, please stay
Yes.
and ask the